All right, hello. Welcome to the first video for this unit. So today we are looking at reviewing some of the stuff you would have learnt about probability in year 9. So what we're looking at, we've got 3 learning intentions. The first one is to understand the language of probability. So we've got some keywords here: trial, sample space, event, and outcome. So you want to become familiar with those words. We want to be able to calculate theoretical probabilities when the outcomes are equally likely. And we want to also focus on using experimental probabilities. So we got language, and then we've got theoretical probability and experimental probability to learn about today. So just to get started, I want you to have a think about these probabilities here. We've got probabilities listed in different ways. We've got a fraction, we've got a percentage, we've got a decimal. Have a think about an event that you think might have an exact or approximate probability that's equal to that. And just give me a reason for it if you think it is exact. So pause the video, have a think, come up with some ideas. I look forward to checking these when we get back into class to go through them. So now we've been able to have a bit of a think about some different probabilities that might occur in our daily lives. We are going to focus on that first learning intention, the language of probability. These words can feel a little bit technical when we first get started, but once you practice using them, then you'll find that you understand things a lot better. And these same words repeat again in year 11 and year 12. So if you can understand them now, it'll really set you up well for success in VCE. So the first one of these words is a trial, a single experiment. So, rolling a dice, flipping a coin, picking a card. That's like one trial, one round of the experiment, I suppose. And I'll get you guys to write these ones down in your book. You might like to even write this explanation in your own words or come up with your own example. If you can do that, it's going to be even more beneficial for you than copying my definitions down. A sample space. So this is all the possible outcomes from an experiment. So if we roll a dice, a one die, then your sample space is just all the different possible outcomes. So you could get a 1, a 2, a 3, a 4, a 5, and a 6. If we're flipping a coin, our possible sample space is going to be a head or a tail. When I use my random student generator, sample space would be all the people in our class. So it's just the possible outcomes that you can get from an experiment. Now, outcome is the result of an experiment. So it's like the result of one trial. So say we roll a die, a possible outcome could be getting a 3. If we flip a coin, possible outcome could be a head. So it's like the answer to your experiment. So trial is rolling the die, and outcome is rolling a 6. Event, a collection of favorable outcomes. So that's what we're looking for. So again, with the dice example, an event could be rolling an even number. So there's actually 3 options for that. You could roll a 2, a 4, or a 6. It's the one that you're sort of looking for in your experiment. Another thing to talk about is long run proportion. So this really links into experimental probability. So this is when you actually do an experiment and you record how many times you get that outcome over a large number of trials. So, maybe you're tossing a coin, you toss a coin 1,000 times. Maybe you don't quite get 500 heads and 500 tails. Maybe you get 490 tails and 510 heads. So Experimental probability is when you actually do an experiment. So that long run proportion is measured that way. So through an actual experiment instead of just there's 6 options, they're equally likely. Now, when we're calculating probability, 0 means impossible. It can't happen. 1 means it's certain. It must happen. So you're always going to get a probability that is somewhere in between impossible, 0, and certain, 1. So if you ever get an answer outside of that, so it's not a fraction, a decimal, or a number in between those bounds, then that's probably a hint. I've probably made a mistake here with my maths. Let's go back and check. When we think about probability, it can be nice to split it up into the numerator and the denominator. So let's think about these ones differently. So the probability of getting a 5. So this is rolling a dice. A probability of getting a 5 here is 1 in 6. So the numerator here is the number of successful outcomes. So in this case, we're looking at the probability of rolling a 5 on a standard 6-sided die. So there's only 1 5 on a die. So that's going to be our numerator. Now let's think about the denominator. That is the total sample space, like the total number of options. So in this case, we're rolling a die. So you could get 1, 2, 3, 4, 5, 6. So there's 6 possible outcomes. So that's where we put the denominator. So write this down in your book. You might want some notes here. And then we're going to have a look at a little example and focus on how to write your solution. We're looking at that second learning intention now about theoretical probability. So, let's think about writing our answer now. Depending on the question, your answer can be abbreviated. The best way to write a solution is as follows. So if you roll a die, find the probability of the following. To find like the probability, a like shortcut way of writing this is we'll write the probability of getting a 2 equals 1 out of 6. Now, over here, I've got the probability of getting not a 6. So anything except 6. Maybe if you get a 6, you're going to go to jail in Monopoly. So you're interested in, okay, what's the probability of getting everything except a 6? To do that, to use that in notation, we use this little dash here, and it means the complement. So it means like the opposite of 6, everything that's not 6. So the possibility of getting not a 6 is 5, 1, 2, 3, 4, 5 out of 6. All right, now let's have a look at our example here. A letter is chosen from the word athletics. Find the probability that a letter is an H. So we're going to start practicing our lovely notation here. We're going to call this the probability of getting an H equals. Now, remember, our numerator is like the number of favorable outcomes. So let's have a look at this word. If we're picking one letter from this word, there is only one that's an H. So that becomes our numerator of our fraction. There's one H. And to figure out the denominator, remember that's the total number of options in our sample space. So let's have a look, try and figure out how many words, how many different outcomes there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability of getting an H is 1 out of 9. Next one, let's have a look at the probability of getting a T. Probability of getting a T. So again, let's focus on the numerator first. The numerator is the number of favored outcomes, like our event. So we have 2 T's in athletics. So if you pick a random number, a random letter from this word, there are 2 possible outcomes that will give us a T. And then before, as we realized, there were 9 different options. So our sample space is still 9. Next, not an S. So we want to find the probability of S complement, S dash. So we can write this as the probability of S dash. So now let's figure out, all right, how many different letters are there here that are not an S? So we figured out there was 9, and I can see 1 S here. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 options that are not an S, and there's 9 in total. So there's 8 out of 9. Now, something to think about here, the probability of getting an S and the probability of not getting an S so the probability of S and the probability of not getting an S has to add up to 1, right? Because you're either going to get an S or you're not going to get an S. So if you like, another way to think about this one could be rearranging this formula here. You might like to think of the probability of S dash, or the complement of S, as 1 minus the probability of getting S. So a little extension activity, try and calculate probability of S dash by doing 1 subtract the probability of S. Back to our final example for this slide, the probability of getting a vowel. So let's call this probability of getting a vowel. I've chosen to write vowel here because if I'd said probability of V, you might say there's 0 because there's 0 V's in here. So let's call it probability of getting a vowel. So again, let us count up the events that we're interested in. So the vowel. So we've got 1, 2, 3 vowels here. And then our total sample space is still 9. Now, if you see this fraction here, 3/9, and immediately want to simplify it, you are on the right track here. So we always want to give our answers in their simplest form. So 3/9, there's a common factor of 3 in the numerator and the denominator. So that's equivalent to 1/3. Okay, let's move along now to our next example. So this example here is about an experiment. So this links into our third learning intention about experimental probability. So what they did is they actually got 3 coins and counted, they got 3 coins, they flipped all 3 coins at once and counted the number of tails. And this is the results after they did that 100 times. So let's have a look at what this means. So if you think about tossing 3 coins, you could get all heads. And then the number of tails would be 0. You could get a head and 1 tail if we toss our 3 coins, and then the number of tails would be 1. So that's what they're measuring here, the number of tails. They did that 100 times and what they got. So now let's have a look at interpreting this information to find some experimental probabilities. So the experimental probability of obtaining 1 tail. So this column here represents the number of times where they got 0 tails. So that happened 15 times. This next one here is the number of tails as 1. And they got that as 20 times. So the probability of getting a 1, while there were 20 times there was 1 tail out of a total of 100. You might like to write this as a fraction. For me, because it's out of 100, it really nicely works as a decimal. But either would be correct. So I'm going to call this 0.2. Because if we cancel the zeros, it's 2 out of 10, 2 tenths. Tenths column, 0.2. Now, the probability of obtaining less than 2 tails. So that might include a couple of options. So less than 2 tails. There were 15 times there was 0 tails. There was 1 time there were 20 times there was 1 tail. So for this one, the probability, the probability of getting less than 2, the number of outcomes, you've got the number of times there were 0 tails, 15, plus the number of times there were 20 tails, the number of times there was 1 tail, which is 20, out of our total frequency, which was 100 trials. So then you get 35 out of 100. And again, you could simplify this as a fraction, but because it's out of 100, it works really nicely as a decimal. So I'm going to write this as 0.35. Now, we also have here the probability of obtaining 3 heads. Now, just pay really close attention to what this question is asking. This is after 3 heads. And this table is telling us the number of tails. So, as we were thinking about before, to get 3 heads, that means you get head, 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 meaning no tails. So to find the probability of getting 3 heads, we're actually interested in the probability of getting 0 tails. And that was 15. There's 15 here who got 0 tails out of 100. So the probability is 0.15, or you can write that as a simplified fraction. Finally, at most 2 heads. At most 2 heads. Let's take some time to figure out what this question is asking us. 2 heads. And at most. So at most 2 heads is telling me the maximum number of heads is 2. So that would mean you'd want to include 2 heads, also 1 head, and 0 heads, but you would not be including 3 heads. So at most 2 heads means 0 heads, 1 head, and 2 heads. But remember, this table is written in tails. So 0 heads, if you've got 0 heads, that's when you have 3 tails. So this is 3 tails. 1 head, that is when you've got 2 tails. And 2 heads means there's 1 tail. So this one is going to be equal to the probability of getting 3 tails plus the probability of 2 tails plus the probability of 1 tail. So that is the 3 tails is 36, 2 tails is 29, 1 tail is 20. And I've just popped these all on the same denominator because each of these would be on a denominator out of 100. So it's 36 plus 29 plus 20 out of 100. So 6 plus 9 is 15. Carry the 1. We've got 3 plus 2 is 5 plus 2 is 7 plus the 1 we carried before. 85 out of 100. Simplify the fraction or write it as a decimal, 0.85. Now, there's actually another way to figure this out that you guys might find useful. And to give you a hint, we can use this answer from before and think about the complement of that. So if you wanted to challenge yourself to try it in maybe a simpler way, try and think about writing the complement of this one to find an answer here. Remember, complement is that dash, meaning not 3 heads. So that's all from me for now. You are going to finish this one off in class. We're going to do a couple of these questions on paper and hand them in. And good luck. I'll see you in class.